Today let us learn a new chapter, that is lines and angles. In the previous video we have discussed about the first chapter and we have just gone through the chapter major points like a quick revision. Now today we'll see lines and angles. Lines and angles. So first thing that we come across in this chapter is point. Place a dot, and what do you call this in terms of geometry? It is a point. Okay, you can name it anything you want, like A or B or whichever letter you like, or you can even say X. That is how we represent a point. Then we have line segment, that is between 2 points. Between 2 points we have a line segment. Okay, this is A. I mean, we can name this as we want. This is line segment and it is represented like AB bar. Okay, that is the shortest path between two dots. A line segment is the shortest path between two dots. Then comes a line. Line goes through 2 points A and B. Line passes through 2 points A and B infinitely. Let's say this point is A and this point is B. Okay, we can name this line with whatever letter we like. Let's say this line represents L. Okay, and these dots represent A and B, and it can be written as A, B bar with arrows. Alright, then we have a ray. A ray is a portion of a line that starts at one point. That this is the initial. Just imagine this is the initial point. Let's say this, we can name it as A. Imagine that is the initial point, and this is the. It doesn't actually have an end point. It goes endlessly in a direction. We have one initial point, and the other one is endless. And it can be represented as A, P bar with arrow representation. Alright. Angle. An angle is formed by two rays. Two rays. Okay. Having a starting common point. This is the common point. Just we'll name these angles. We'll name 2 points from these angles. We'll name the vertex A. Okay. This common point here is the vertex, and B and D are the arms. This is the vertex and these are the arms, and we can form an angle here. Then how can we name this angle? We can simply use a vertex and say it is the angle. Here, what have we given the name to the vertex? We have given the name A. So, what is the angle? Angle A. We call it angle A. We can say this is the symbol of angle, and we can name this angle like BAD. Okay, we have so if you take a line, you can measure it with a scale. A straight line can be measured with a scale. Then how do we actually measure the angle? If you can, the size of an angle is the amount of rotation or turn that is needed about the vertex to move the first ray to the second ray. What does that actually say? See, this is vertex and this is the amount of turn, the size of the angle. The size of the angle, how can we measure the size of the angle? We can measure the size of an angle using protractor. Like if you see, a straight line can be measured with a measuring scale. Likewise, we can measure angle using a protractor. See them in compass. For example, you take a compass or a divider. We can turn the arm to form an angle, right? The vertex is a point where the two arms are joined, right? That is where we have. And even if you take scissors and in the letter X and in some of the letters in Y also we can find angles. Likewise, in some alphabets also we can find angles. Here you can see angle, here you can see angle, here you can see angle. Likewise, we get to see so many angles in the alphabets as well. Now, how do we actually compare angles? How do we actually compare angles? If you see an example of a book, um, when a book is opened this way, it is forming an angle, and opening a book this this way is also forming an angle, right? And we can see a table crosses across a table. Here also an angle is being formed. A 90-degree angle is being formed. Angle, and if you take this angle, if you superimpose this angle on this, we can find which one is larger angle, which one is making larger angle, or and which one is making a smaller angle. By superimposition, we can find which angle is greater or smaller. Equal angles will just superimpose by themselves. So, is it always possible to compare angles with superimposition only? Don't we have any other ways of finding which is greater angle without superimposition? Yes, we can. For example, if two birds are opening their mouths wider, how can you know which one opened bigger, which one opened larger? We can do that by tracing these angles and superimposing them, right? So one of the methods of finding the angle measurement is by tracing also. First is comparison and then tracing. So if you take this angle and trace it on a paper, and you take this angle and you trace it again, you can easily find which one is bigger. It's almost like comparing only. Angles. Just imagine you take a paper, a, a plain paper. If you place it somewhere on a surface, it will be straight. But yeah, it will be straight. Okay. And if you fold it, if you fold it and you again place it, if you fold it and you again place it, what will happen? It will make an angle and it will be a little difficult to make it a complete straight line, right? But here, what is the angle it is forming? It is forming 180 degrees. And what is the angle it's forming here? It will be around 135 or something like that. Just let's assume it is 135. But here, if any object is making a straight line, and if you see the angle that is made from the middle of it, it will always be 180 degrees only. Okay. And this type of angle is called straight angle. Okay. Angle like this, it is 90 degrees. And this is called right angle. Okay. Then is right angles. One more point I forgot is right angles are always two perpendicular lines only that meet at the right angle and make 90 degrees. Anything that makes 90 degrees. How do we actually measure angles? We measure angles using a protractor. We measure angles using protractor. It will be like this in this shape. You must have already seen a protractor. And you will have numbers, give some numbers here and so on. You will have the angles being shown here like this. All the angles will be shown, but the basically it looks like this. But what is the logic behind using a protractor? Why do we actually use a protractor to compare two angles? We can actually quantify how big an angle is using a number without having to compare it to another angle. Is it even possible? No. To know the precise measurement of the angle, mathematicians came up with an idea. They divided the angle in the center of a circle with 360 equal angles. The angles are nothing but the parts. These are 360, right? An angle measure of each of the unit part is 1 degree. Like 1 degree. Measurement of different angles. We have more types of angles and their measurements. Again we have to see some of the sorry types of angles. We have acute angle. Acute angle, the angles that are smaller than the right angles. Okay, it is 90 degrees to 0 degrees to 90 degrees. These are acute angles. Okay, and a right angle is, we already know, any angle that means measuring 90 degrees is a right angle. We have obtuse angle. Obtuse angle measures from 90 degrees to 180 degrees. Then we have reflex angle. Any angle that is greater than 180 degrees. Any angle that is greater than 180 degrees and which lies between 180 degrees and 360 degrees is a reflex angle. Okay, as that's all. Sorry, that's all, everyone. This is just a quick revision of lines and angles. Thanks for watching.